Okay, so right now we're going to do the vertex formula a little bit. Not too much of it because I'm really not too worried about it. The vertex formula is h of x is equal to x, or
x minus 8.
Sorry, f of x. I think f of x is equal to x minus h.
We can't erase pen.
Squared. Yeah, you can. It's erasable pen.
Did you not know that?
No.
Are you serious? Really?
No, I did not know that. That's cool. I heard about it, but I heard like they're kind of hard to find.
Alright, so f of x equals x minus h. Might as well just write this over because it's all orange and you can't see it. X minus h squared plus k, right? And so what's happening is we talked about this when we were doing the linears, right? Whatever happens to the x, it always does the opposite, right? And that's where this opposite sign's coming from, the negative sign. It's always the opposite, right? So if it's right 2 or plus 2, it's really minus 2, right? So, but whatever happens to the whole function, right, is k, right? That's the vertical. That's the vertical change, the vertical shift. Okay? So when you look at this function, right, you can see that the original function looks like this. That's f of x equals x squared, right? So what happens with this function is that you can use this and go, well, h must be 1. So that means that it's got a horizontal change of 1. And it looks like this, right? So that's what's happening. Now we talked about it a different way. We said, hey, if it's happening to the x, then that's x opposite, right? Opposite of minus 1 means x plus 1. That means it's right 1, right? So we translated it backwards, right? The x's always do the opposite. When we go right 1, that means opposite of plus is minus and gets us back to the minus. So that's what we talked about last week on the last test. That's all they're really having you do. Except here, they want you to be able to find the axis of symmetry. They want you to find the y-intercept. They want you to find the vertex. Well, heck, that's the whole 4-step method that I showed you the other day, right? That's this 4-step method, and we just break it down real quick. Yes, sir?
So would it be better if we wrote that too?
Yeah.
Okay.
Okay, so I'm going to break this down doing the 4-step method. Remember, we want to find the first derivative. Remember the derivative, right, was deriving from the original function, right? And derivatives are derived through the slopes. So we can tell that this slope is negative and this slope is positive, right? But the slope here at the base, well, that's 0, right? The slope at the very bottom of the quadratic is 0. And that's why we want to set the thing equal to 0. We want to see the derivative equal to 0, the slope. When is the slope equal to 0? Right? Where, in other words, is the slope equal to 0? So we find the derivative and we say 2 times 1 is 2. And we say 1 times 1 is 1. Right? And then what we do is we set that equal to 0. Okay? And now I can solve.
Yeah.
So I solve by subtracting 1. I get 2x is equal to negative 1. Then I divide by 2. And I get x is equal to negative 1/2. This is my axis of symmetry. Okay? My axis of symmetry. And so at this point, I can see that my axis of symmetry is at -1/2. Okay? I'm not going to draw it till the end. I'll graph it at the end. That'll give you a good check. Alright? Next spot is number 2, finding the axis of symmetry. So what I do is I just plug it in, take this, plug it in to the original function. Right? So the original function is f of x is equal to x squared plus x minus 2. And you notice every time I said the variable, I wrote the parentheses. Okay? You don't want to just, you want to keep it as simple as possible. Throw in your parentheses. So now I can plug things in. 1/2, -1/2, right? And so from there, I solve the math. -1/2 squared is 1/4. -1/2 is -1/2 or 2/4 minus 2. So now I've got, write those again, 2/4. So 1/2 minus 2/4 is -1/2 minus 2, which is minus 2. Wait a minute. Minus 2/4 minus 1/4 minus 2/4 is 1 minus 1/4. And this is going to be more minus, so it's minus 1 and 1, or 2 and 1/4. Okay? So that's what f of -1/2 equals. So I could easily write that as the vertex. -1/2, comma, -2 and 1/4. That is my vertex. Okay? So that's step 2, finding the vertex. So, from here, I want to go to step 3. Step 3 is the easiest step, right? Step 3 is f of 0 should equal c. And in this case, think of c as ax squared plus bx plus c, right? So c's right here, it's -2. So f of 0 should be -2. Is it? Well, you plug it in, you're like, well, if f of x, or f of 0, is equal to x, or, excuse me, blank squared plus blank minus 2, and these are zeros, right? Then those go away. 0 squared is 0, 0, minus 2, minus 2. So that's pretty simple. It's always simple. Okay? That's why we use it. What this also is the y-intercept. It's where it intercepts the y-axis. So the point is 0, -2, and that is the y-intercept. Okay? And so now you want to do the check-it method. There's 2 parts to the check-it method. The first part is just check it. What I should have, alright, is f of 2 times the axis, and then in this case the axis is -1/2, right? So 2 times -1/2 should equal, and so what is 2 times -1/2? -1, right? So half of 2 is 1, and negative times positive is negative. So -1, and I just got squared plus minus 2. So this is -1, and this is -1. So -1 squared is 1 plus a -1 minus 2. These cancel, I get minus 2. So it checks out to be good. F of x of -1 equals -2. So now I can write that as a point, -1 and -2. And that's my other symmetrical point, right? Point of symmetry. And now I can do my last check. My last check is graphing it. Okay? If I want to graph it, I got to have I got to be able to do halves. I've got to be able to do 1s and 2s. So I'm going to spread it out a little bit and go 1, 2, 1, 2, 1, 2, 1, 2, right? And now I'm going to graph the vertex is -1/2 and down 2 1/4, right? And the -1 and -2, so I'm going to go -1 and down -2, so that's about right there. And then I'm going to go 0, -2. And that should look like a parabola. And if it does, then you should have done it correctly. Alright?
Yeah.
Questions?